So we are on to the second day of 4.4, and again this is pre-recorded, so no entertainment value, all pretty serious business. So we're going to start out with the mean value theorem, and so remember that we've already studied the mean value theorem in chapter 3. Not sure how many of you remember that, but here's a quick review on that, and the picture that I'm going to show you should be familiar to you, hopefully, because we have seen it before. Oops, that's not the one. That's the one. Okay, so here's the mean value theorem from chapter 3, and just a quick review on that. What that theorem is saying is that if you've got a function f, so for example, this is your function f, okay, then the mean value theorem for differentiation, and we're going to be doing a mean value theorem for integrals in a minute, but for derivatives the mean value theorem is saying that, hey, if you've got a function like that and you've got 2 points on that curve at x equals a and x equals b, then the mean value and the function is continuous and conditions are met that fa is not equal to fb, blah 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 and so on, that there's going to be some point on that curve x equals c such that if you were to draw a tangent line at that point, then that tangent line is going to be parallel to this secant line here. Okay, so this is your secant line that joins the 2 points a comma fa and b comma fb. So that's pictorially, and mathematically this is what it means. Okay, it means that the derivative of the function, okay, is equal to the slope of the secant. So remember, this is the derivative, and you guys by now should know that derivative is equal to the slope of the tangent line, okay, is equal to the slope of the secant. And pictorially that means that the two lines are parallel, the tangent and the secant are parallel. Okay, quick review from chapter 3. Well, what does the mean value theorem for integrals look like then? Okay, what does the mean value theorem for integrals look like? So here's another picture. And this is what the theorem looks like, pictorially at least. Okay, let me explain to you what it means. Okay, so by now you should know that the integral of fx dx between the limits of a and b is equal to area under the curve. Okay, so the yellow shaded region there is this integral from a to b. The mean value theorem is telling you that there is a value c, okay, some point c, okay, where if you are to draw a rectangle whose height is f of c, then that area is going to be equal to the area underneath the curve. Okay, and this is what it means, okay, right here. I couldn't do the definite integral of fx dx in this application, so I'm going to write it down. So remember that this here is the area of the rectangle. Oops. Is the area of the rectangle. And then on the other side, I should really put down in mathematical notation a to b fx dx. Then this here is equal to area under the curve. Okay, that's what the mean value theorem of integral is saying. Okay, that you can always find a point c between a and b such that if you are to actually, this is kind of strange. That shouldn't be c. Let's see. I need to change this slightly, move this point. So this point is not C, okay? This point here is C, because this height here is F sub C, okay? Right? Nothing wrong with the picture other than C shouldn't be there, okay? So you can find a point C between A and B such that if you are to draw a vertical line from C until it touches the function, then that would define the height of a triangle, and then the area of, height of a rectangle, and the area of that rectangle is going to be equal to the area under the curve. Okay, so that's what pictures are telling you, and obviously in calculus, being a mathematics class, that's not sufficient. So here is the mathematical definition of the mean value theorem for integrals. So on the left hand side again, you've got area underneath a curve defined by an integral. On the right hand side, you've got the area of a rectangle whose width is b minus a and whose height is fc. Okay, so this is the mathematical definition for the mean value theorem. Okay, well, let's start doing some examples. So I'm going to do number 44 on page 291. So let me bring my book up, and I need to go to page 291. And let's see what the question was. Let's see, that was number 44, am I right? Yes, number 44. So going to and it's supposed to be on page 291. Wow, this book's got a lot of stuff in there. I think you should be reading this thing, huh? Number 44. Where are we? Okay. Find the values of C guaranteed by the mean value theorem for integrals for the function over the given interval. So we are doing number 44. Let me go snip this guy. I don't know how big that's going to be. Hopefully there's enough space in there. Okay, so you've got fx equals 9 over x cubed. So if you kind of graph this graph when x is 0, it should be going to an asymptote, and when x is going to infinity, it should be going down like this. And the 2 points of interest are 1, so this is A, this is B, and the mean value theorem is telling you that let me get this shaded region. So here's your shaded area underneath the curve. Okay, the mean value theorem is telling you that there is some value C such that if you were to draw a rectangle, okay, then the area underneath the rectangle is equal to the yellow shaded area. Okay, so mathematically, let's just go do this stuff. So you've got integral 9 over x cubed dx from 1 to 3 is going to be equal to b minus a, so it's going to be 3 minus 1 times f of c. Okay, and the idea is to find c. Okay, and remember that c is going to be between 1 and 3. So this is 3. Right. Okay, let's just go do the integration on the left hand side. So first you're going to rewrite this. So it's going to be 1, 2, 3, 9x to the minus 3 dx. And on the other side it's going to be 2. And f of c turns out to be 9 over c cubed. All you do is you take the c and you shove it in there. Okay. I guess it doesn't let me expand this. Oh well. So on this side here, when you integrate, you go to add by 1 and divide by the new number. So it'll be minus 9 over 2. Okay. Minus 9 over 2 from x to the minus 2 from 3 to 1. And on this side, you've got 18c cubed. So if you evaluate this guy by plugging in 3 in there, so you get a minus a half, and then subtract, and then a plus 9 over 2. Okay, so first you put in 3, so you get 3 to the minus 2, which is 1 over 9. The 2 9s cancel to give you a minus a half. Then when you do this bottom limit, you're going to stick a negative sign, so that negative and this negative becomes a positive, to 9 over 2, and so this gives you a 4, so c cubed equals 9 over 2, and c is equal to cube root of 9 over 2. Well, is the cube root of 9 over 2 between 1 and 3? Well, let's go find out. Okay, let's go find out. So you've got 9 over 2 is 4.5, and you want the cube root of that, so that's 1 divided by 3. Sure enough, it's between 1 and 3. Let's just go ahead and check the answer in so we need 4.4, so we're going to page 385. And I thought we were doing number 44. So let's go take a look at 44. And the answer is cube root of 9 over 2, which is 1.6510. All right, so that's the mean value theorem. Okay, cube root of 9 over 2, and I have cube root of 9 over 2. So that's the mean value theorem for integrals. Okay, mean value theorem for integrals. Let's see, I guess the next thing will be more examples. Oh, well, it's saying calc number 7 and then calc number 2. No, what's that mean? Oh, I see. Okay, so for calc number 7 gives you the area underneath the curve analytically, and then you can always solve. So let me just kind of quickly review that. Okay, what are they trying to do? Let's go snip this. So we had integral 1, 2, 3 of number 44 was 9 over x cubed. It's 9 over x cubed. So that's 9 over x cubed dx was equal to b minus a, that's 2, times 1 over c cubed. Okay, you wanted to solve for c cubed. So what I'm trying to tell you to do here using the n box is do this on your graphing calculator. Okay, so let's go do that. Okay, you're going to put in y1, you're going to put in 9 divided by x to the 3. Okay, you're going to graph that, and you're going to do an integral. So you're going to go second calc number 7, that's the integral. So the lower limit is 1, upper limit is 3. You find the area, and you get the number fx dx equals 4. Is that what we had? 9 over x cubed. And so you get that is equal to 4. Okay, I think I'm going to pause here for a minute and see what's going on here. Yeah, so that was 4 indeed. Okay, so what I'm asking you to do with the calc number 2 is then what you're going to do is you're going to take this equation that you have, 4 equals 2 over c cubed, rewrite this so that c cubed equals a half. Yeah, I'm not sure. Oh, I know what's going on. Okay, there should have been a 9 here. That's what's missing. So there should have been 18. Okay, now it's coming back. So c cubed is equal to 18 over 4. And then to do that, what I'm saying is that just put this equation in your graphing calculator and find second calc 0. So go back to